So this problem here, we have the half-life of caffeine in people's bodies varies from person to person, average about 5.5 hours. And A part says a grande at Starbucks coffee contains 330 milligrams of caffeine. After drinking this coffee, how long before there's 30 milligrams of caffeine remaining in our system? Well, in order to figure this out, we have to understand this idea of a half-life. And what a half-life does is if, let's say, we start off with 100 milligrams of caffeine, half of it is 50 milligrams. And so it will take 5.5 hours to degrade from 100 to 50. If I had, let's say, 800 milligrams, half-life would be 400 milligrams, and that would take another 5.5 hours. And so if this 400 to go to 200 hours would also be 5.5 hours. And so this is an exponential decay situation, and so I have to make a model that's going to deal with exponential decay. And so what I can say is that my initial amount of caffeine times some rate of decay to the power of t is going to equal to what the current caffeine level is. And so this is the initial amount of caffeine. Well, I need to find what my B value is. My initial amount was 330 B to the T. Well, if I want to do my half-life of 5.5, my T is going to be 5.5. And if there was 330 to start, well, half of 330 is going to be 115. If I divide by the 330 here, I end up with 1/2 is equal to B to the power of 5.5. And so now to find B, I'm going to raise this to the power of 1 over 5.5, raise this to the power of 1 over 5.5, and so B will be 0.5 to the power of 1 divide 5.5. And I get 0.8819. And so caffeine is equal to the initial amount of caffeine times 0.882 to the power of t. Well, for this particular scenario in Starbucks, I'm talking about a mug that is 330 milligrams. And so this is my model that I'm going to have. And I want to find out how long before there's 30 milligrams of coffee in our system. Well, that's 30 is equal to 330 times 0.882 to the power of t. So I'm going to divide by 330. And it's equal to 0.882 to the t. And so now, in order to do this, I'm going to change it to, have to convert from logarithms, so it's going to be log base 0.882 of, well, that cancels of 1 over 11, because it's 11 is equal to t. So if I go to math, log base, take all the decimals and I'm going to do 1 divided by 11, and it says t is equal to 19.0. So 19.0 hours, there is going to be 30 milligrams of caffeine left in your body's system that long. So the second part says how much caffeine remains in the system after 7 hours. Well, for B part, that means I want to find C at 7, which is going to be 330.882 to the power of 7. And so using that 330 times this value, getting all the decimals, so my answer is as accurate as it can be. When I round it, it's the power of 7. So it is equal to 137 milligrams is remaining with 7 hours to go.